All right. Lesson 3, Unit 6, Geometry, tests for parallelograms. And so we're going to hit a few more theorems, which are basically going to be converses of the other theorems that we learned. I already told you that that's probably going to be in there. And then we're going to do an example with a little algebra, and then we're going to sneak in a proof. I'm kind of excited. I had an idea about how to present this proof that I think is going to be good. So you have to let me know in the comments whether it's a useful thing or not. So we've got a few theorems, four, I think, right? We have four theorems. Yeah, four theorems we're going to look at, which are basically converses of the other theorems. So the first one is if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So we got a picture that matches that. So if you have a quadrilateral, so a four-sided polygon that has, and you determine that the opposite sides, both pairs of opposite sides are congruent, then you can say definitively it is a parallelogram, right? So let's look at the next one. The next one is if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. Same thing. So if we've got a quadrilateral, four-sided figure, and that we determine that both pairs of opposite angles are congruent, both of them, not just one, both of them are congruent, then we can say it's a parallelogram. This quadrilateral is a parallelogram. The next one is if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. Same thing, right? So we've got a quadrilateral, we have we have diagonals drawn, and we determine that they bisect each other, so each side is congruent to the other side, right? That's kind of definition of bisector, right? Then we can say that it is a parallelogram. Great, right? Last theorem, and then we're going to get into some examples and such, right? Last theorem is if one pair, this one's nice because pretty much everything else we had to have a pair of things, two opposite sides or two pairs of opposite sides are congruent, two pairs of opposite angles, or both diagonals bisect each other, all of those things. This particular one is particularly nice because I don't know. It's fine. Get over it. Right? Because we only have to have one pair of sides. Right? So if we determine we have a quadrilateral and one pair of sides is both, it still has to meet two conditions, has to be both congruent and parallel. If we figured that out, then we can say that the quadrilateral is a parallelogram, right? Easy peasy. Let's do an example with some algebra. This is the kind that y'all like. And then we'll do a proof. And then we'll be done, right? What are we? We're clocking at 3 minutes right now. We're doing great. If the measure of fk is 3x minus 1, so fk is 3x minus 1, kg is 4y plus 3, kg, so this one is 4y plus 3, jk is 2y plus 3, that's this one right here, and kh is 2x plus 3. Find x and y such that the quadrilateral is a parallelogram. So in order for this to be a parallelogram, these two diagonals have to bisect each other. So the first thing I'm going to do is I'm going to go in and I'm going to label on the picture what's given, because that makes our life a little bit easier. So fk is this one, so that's 3x minus 1. That's this diagonal right here. Kg, so kg, that's this one right here, is 4y plus 3. And then jk, so that's this one right here, is 2y plus 3. And then kh is 2x plus 3. Right. Okay. So these have to bisect each other in order for this to be a parallelogram. That's what condition we're trying to meet, which means that this guy's got to be congruent to that guy, and this guy's got to be congruent to that guy, because that's the definition of bisector, right? And they bisect each other. So these are pretty easy. This one's not that difficult at all. This is congruent to that, so we set this equation, 3x minus 1 equals 2x plus 3. All right, I'm gonna slow really down. I've noticed I noticed the other day some of my students in class are like struggling with some of the algebra bits, and so I'm gonna go even a little bit slower on these than I normally do, and make sure and walk these through, and make sure we really know what we're doing. So if you are one of my students and you have been missing stuff on the algebra, make sure you like slow down with me and really pay attention to what's going on here, because these things are not necessarily hard, but if you don't know them, then you're gonna have trouble, right? And you're gonna continue to have trouble this class and the next one, and all of those things. So, all right, so we got to get and solve for x right here. So the first thing, we've got x's over here, we've got x's over there, so we need to get the x's together. So when we're moving across the equals, so we're trying to take and we're trying to move this one. We're trying to move him over across the great divide that is the equals. This guy right here, right? If we're moving something from one side to the other, we have to change signs. We're either going to add or subtract, and you have to do the opposite sign. So since this one is 2x, to get rid of it, we want to subtract because it's positive 2x. So minus 2x, and then we got to do both sides. And we're talking about sides. I've seen this in my Algebra 1 class. I've seen this in the geometry class as well. So when we're doing there, when we're talking about size, we're talking about the equals, right? So a great idea is to do exactly what I just did and do a dotted line through the equals. That way you can know what the two sides are that we're talking about, right? So we're going to subtract 2x from this side, and if we do it to this side, we've got to do it to the other side, and we're going to put it with his friend, the one that matches. So we're going to do minus 2x over there, right? 2x minus 2x cancels, which is what we want. 3x minus 2x is 1x. When it's a 1, we don't have to write the 1, right? So it's just x minus 1, and then we've got equals, and then we're going to bring down what we haven't touched. We're going to bring down that 3. Now remember, when we're solving an equation, our entire goal is to get the variable, x in this case, by itself, right? So we got to get the stuff off of the x. So what is still attached to the x? Well, a 1 is attached through subtraction. We've got to do the opposite, the inverse, to get rid of it. So we've got to add 1. And then if we add 1 to this side, we've got to go to the other side of that equals, go to the other side of our dotted line, and we got to add 1, right? That's going to cancel, leaving us with x equals 4, right? Easy peasy. I'm going to go just a titch quicker, but still take the time to do all the steps and all the things in these equations. Because I want to make sure we're getting this and getting this well. So for our other one, this is congruent to that. So we're going to say this equals that. That's how that works. That's how those equations works. Easy peasy, lemon squeezy. So we've got 2y plus 3 equals 3y. No, what am I writing? That's a 4. Did y'all know that? It's a 4. 4y plus 3, right? So again, we're going to go ahead and split this. Going to put a dotted line over our equals so we can know what sides we're talking about. We've got y's, we got BFFs that are hanging on. One's over here and the other one's over there. So we've got to bring one to the other. Now, you don't have to do this. I very often like to always move my variables to the left. We could just as easily subtract 2y as subtract 4y, but I like to go ahead and move my variables to the left because that's usually where I want them in the end anyway. So that's what we're going to do here. So we're going to, this positive 4y, we're going to subtract the 4y from this side. If we do it to this side, we got to do it to that side. We're going to put him with his friend, so minus 4y. That cancels. 2y minus 4y is negative 2y. Bring down what we haven't touched. So we're going to bring down our plus 3, bring down our equals, bring down our other 3, right? Easy peasy. We've got 2 things attached to the y. Now we can get rid of this negative 2 or this 3, right? It's usually easier to get rid of the addition and subtraction stuff first. So that's what we're going to do. So this is added. We got to do the opposite. Opposite of adding is subtracting. So we're going to do minus 3, and then we do it over here, minus 3. This cancels, leaving us with negative 2y. We're bringing down everything we haven't touched, equals 3 minus 3 is 0. 0 is a number. Sometimes this will freak people out and we'll get confused and all of those things. On a problem like this, yeah, you might, I've seen people get confused and they're like, oh no, what do I do? How is this going to work? 0 is a number, so just write down 0. 3 minus 3 is 0, right? It doesn't, it's, I've seen a mistake I see sometimes, even sometimes up into algebra too, is people will be like, oh no, they'll do that and then they'll be like, I don't know what to do, and it just like breaks, right? 0 is a number. Okay, that's the moral of that story. Equals 3 minus 3 is 0. So this -2, how is it attached to the y? If the number is right next to a variable, that's multiplication. Number next to variable, multiplication, right? And so how do we get rid of multiplication? We divide. So we're going to divide -2 on both sides. -2, and then over here, -2. This one cancels, leaving us with y equals 0, because 0 divided by -2 is 0. Easy peasy. Let's hit a proof, and then we're going to be through. Okay, so here is the proof. We've got this shape as part of our given, and we've got this given. I decided to write the given into the thing. Usually this will be the first line and whatever else. I just decided to save space on the screen and just stick it in the T-chart already. So if ACDH is a parallelogram, so that's the big one, ACDH is a parallelogram. So we know that this big shape is a parallelogram, which includes all of the things about parallelograms. We'll get into that here in a second. We also know that B is the midpoint of AC. What does midpoint tell us? That tells us that one side is congruent to the other side. Their measures are equal. That is something we may be able to use, right? When you're reading the given, those are things that you need to be thinking. You need to be putting those into your brain of what is this thing that I've been given? What does it tell me? So, and then you can in turn use that as a step in your proof. We're also told that F is the midpoint of HD, right? So that's, again, going to tell us that this is congruent to that ultimately. Now, before we dive in and we start doing the proof and I start just like putting stuff on the page, I thought I made a layer on here when I was making this file and getting ready to make this video. I was looking at this proof and wanted to make sure that I had in my brain wrapped around the path that I was going to go to get to prove this so that I could, have something coherent and cohesive when I presented it. And so I made notes and whatever else as I was doing that. And it dawned on me as I was jotting these down, is I could leave that layer in here and then just kind of talk you through the sort of before I tackled this proof like regular. And I was thinking that for some of you, if you're still struggling with proofs, that this that I did could be a great idea to have, kind of a scratch paper side and just kind of start playing with things and thinking through bits before you because sometimes going into the formal proof where you're having to put a statement and justification, you're trying to do all that. It can be a roadblock because you're trying to think about too many things at once. So it might be easier to include a step kind of like what I did, where I did kind of an informal and I had the justifications in my head and I was writing stuff. And so let me show you what I did. So here's the notes. Let me kind of talk you through what I did. So when I was doing this, actually forget that. Let me just do this again. So I'm going to undo that because I realize as I put that up on the screen, that's just going to be confusing. So I'm looking for this and I'm trying to prove that ABFH is a parallelogram. So when I'm thinking through a proof and I'm trying to do it on my own, when I'm trying to come up with a proof, I'm kind of starting to think through things. So the first thing I want to think is where is this shape? Where is ABFH, right? So ABFH is right here. So we're talking about this parallelogram right there. That's ultimately what we're trying to prove is parallel. Okay. Now I'm also going back and I'm thinking through all of these things in here, right? All of those, all those 4 theorems that we talked about at the beginning. You have it in your notes. You can see it easier, right? So I'm thinking, okay, so I could be trying to find that this is congruent to that and this is congruent to that. I could be trying to prove something like that. I could so opposite sides are parallel. I could be trying to use that one. I could be trying to use opposite angles are parallel. I could be trying to do something about the bisectors. Now, the bisectors aren't drawn there, so I'm probably initially, until I see something else, going to be like dumping that one out of my brain and not even thinking about the diagonals ones because they're not drawn on this shape, right? And so I'm probably not going to use the diagonals, the fact that diagonals bisect each other. I could also be using the fact that one set of sides one pair of sides is parallel and congruent. I could be going for one of those things. So I need to be kind of thinking, okay, what are these things? So then after I'm doing that, so this is what I'm trying to prove. Then I'm starting to think, okay, in my head, just in my scratch paper zone, okay, what does the given tell me? Well, I'm going to have to put these as actual statements, but I'm looking, okay, B is the midpoint, so this is congruent to this. This shape over here is over there. I'm also told that F is the midpoint of HD, so I know that this is congruent to that. So then I'm also told that the big shape is a parallelogram. What all things can I get from that? Well, I can get that this side is parallel to that side. I can get this side is parallel to this side. That's going to be in there. I could also get this. I could get these opposite angles are congruent. Something like that. I could be told that. I can also say that this big shape is congruent to this big line, because opposite sides of a parallelogram are congruent. So I could say that these are congruent. So those are some things that I can say from that. So now that I've kind of got that big, I've just scattered everything, then I'm diving back in and thinking, okay, so what is useful? Well, so the first one, I'm going to be thinking about the first, just like you're probably going to do. I'm going to look at my notes and I'm going to think about the first theorem. So can I prove that opposite sides are congruent? So can I prove that this one is congruent to this one, and then this one is congruent to that one? Okay, maybe I could try to do that. So I could try to get from this one's going to be pretty easy, probably, because we've got some congruent things. Probably do something with substitution, maybe, because I've got segment addition. I've got this segment adds up to that segment. This one adds up to that one. This one plus this one is this big one, right? Something along those lines. I probably have something. So these two are probably easy. But angles, well, I've got parallel lines. These big ones are parallel lines, so I can kind of do alternate interior and do substitution. I can kind of get something with that. As I'm looking at this and as I'm thinking through this, and this is kind of what I got, is the more things I kind of played with in my head, the more I was like, it's going to be really difficult to get to this line, right? Because I know stuff about the big one, and so I can say stuff about this guy and these sides. So those sides I can say, I can get this angle and that angle way over there, but it's going to be really hard to get to this middle one. So the more I'm thinking about this, the more I'm like, okay, I can't get to this middle one. So I've got to take a breath and stop and go back and think through this. Okay, I can't get to this middle one. So I can only get to these outside sides. So this one right here and that one right there. Do I have a theorem that lets me use just two sides? Yes, I do. I have the one where, okay, so if I prove that these are both congruent and parallel, then I've got this in the bag, easy peasy, lemon squeezy, done and dusted, easy, 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 right? So that's going to be where I'm going to try to go for. So then I'm going to be going for getting this. I need to be able to prove that this is congruent to this one, and I need to be able to prove that they're parallel. Well, I'm pretty much given that it's parallel because of this parallelogram. So I've got that those are parallel straight up. That's already there, right? That's going to be easy. That's in the given, right? I need to say it, right? Since it's parallel, AB, or since it's a parallelogram, AB, because AB and AC are the same thing, right? On the same line. So AB is parallel to HF. That's easy. I can say that they're parallel because it's a parallelogram. Blammo. opposite sides of a parallelogram congruent. That's easy, right? So I'm not even going to worry about that. That's going to be easy. What I do need to think about is how can I get that these are congruent? So then I'm going to start kind of writing. Then I'm going to start kind of jotting through what I have and whatever. And I'm not going to worry about like writing down every justification. Like, okay, so I know that AB equals BC, right? I know that those two things are equal because midpoint, right? I know that HF equals FD because midpoint. F is the midpoint of HD, right? No problem. I also know that the measure of AC is equal to the measure of HD because opposite sides of a parallelogram are congruent, right? So I've got some things. When I have these sort of binary things, these are things when you're thinking through this, I'm taking plenty of time on this video because I'm trying to kind of, I'd already said this, but I'm trying to kind of hit some of the spaces that I'm seeing people still struggle with. So that's why we're taking a little bit more time on this. But when I have these binary equivalencies, right? This equals that, just this X equals Y, right? When I have that, I am thinking, okay, I can probably substitute these into something, right? I can put these into something, right? And so what else can I say? Well, I've got some segment addition. I already said something about that earlier, right? I've got that, oops. That is what I wanted. So I can say that AB plus BC equals AC, right? This little one plus this little one equals the big one, right? Segment addition, straight up. That's easy peasy. I can definitely say that. I can say the same thing on the other side. So HF plus FD equals the big one. So HD, right? Now, I've got some things happening. So as I'm looking here, I want to kind of look and see what matches. Like that's kind of what I'm going with here is where do I have stuff that matches? Well, I have this that matches. I have it matching over here. I should not use pink, but what I should before I do that, where am I trying to go? I'm trying to get AB is going to HF. So that's what I'm trying to I need that for my proof. So let me find in pink, where are ABs and BFs or HFs? FH is this one and that one. Where are those? So I've got this one and that one, and I've got it again right here and right there. So those are there. Now, what do I have that matches? Well, I have AB that matches right here, and I have HF that matches with HF down there. So, and then I've got BC that matches a BC over here. So whenever it matches from up here to down here, I can take something from up here and stick it down there, right? So I know that those are things that I can ultimately do eventually, right? I'm kind of running out of colors here. Let me grab something different. A more differenter thing. There you go. That'll work. Sure, why not? It's going to be ugly, but whatever. This is going to match with that one, right? Just finding stuff that matches. This AC matches this one, and this HD matches that one. So as I'm seeing things that are going to match, I can think about where I'm going to substitute. Well, what I need to be is I need to be in AB and HF only. So can I get stuff to match and disappear and whatever else? So I can take and I can replace one of these with the other one, right? Because AC is HD, right? So I could take and I could put HD in there, right? Then these sides will be the same. If they're the same, then I can set them equal to each other sides equal. I can do all that, right? I want this in terms of AB and HF. Well, AB equals BC, so I can turn this BC into an AB by taking this AB and sticking it right there, right? Then I've got AB and AB. It's only in ABs, right? I can get, and I also want HFs, right? Because HF over here, right? So I can try to get and make this HF and stick him in right there. And then I've got those matching. And then I've got this side matching that side. So let me write down what I have. Let me write down what I've done. So I can turn this into AB plus, why is that ginormous? I can turn this into AB plus AB equals HD, right? That's what we replace this top one with. And then on this bottom one, I can turn it into HF plus HF equals still HD. Now look at that. Now on this next bit right here, right, I can set this side equal to that side because they're equal to the same thing. And I'm also going to show this on this because I'm going to write this formally in a minute, that 2AB equals 2HF, right? Because AB plus AB is 2AB, right? HF plus HF is 2HF. And these two are equal to each other because they're both equal to HD. And then I can divide the two off, and AB equals HF. That's what I'm trying to do, and then I'm there, right? Anyway, that's the thought process and the just generic notes that I used to make sure I knew what I was doing. Let's walk it through more formally, right? So, step number 2. Let's start saying stuff that I know I can say. So step number 2, let's say that AB equals BC is congruent to BC, right? So AB congruent to BC because definition of midpoint, right? By the same thing, I can say this is congruent to that. So HF is congruent to FD because definition of midpoint. Remember I've said repeatedly over and over again that it is very useful to go back to your given and think about what I can figure out from the given. And this is what I can tell from that part of the given. Definition of midpoint. Of id point. Midpoint. Midpoint. Great. Right? So I can also say that the measure of AC equals, or I can say that AC is congruent to HD, right? Why can I say that AC, so this big one over here, so this guy is congruent to that guy right there, because opposite sides of a parallelogram are congruent. So step 3 is going to be that AC is congruent to HD because opposite sides of a parallelogram are congruent, right? Easy peasy. No big dealio, right? I can also go ahead and say, because it's useful because of the same part of the thing, I may as well go ahead and say that AB is parallel to HF. AB is parallel to HF because opposite sides of a parallelogram are parallel. Right? So I've got that bit. Now I just gotta get this is congruent to that. So now we're now we're starting to dive into all the little things. We got all the little congruents, all the little things. Let's turn these congruents into the measure ofs and equals and all that stuff. so that we can use them in the other things. Let's go ahead and do that little housekeeping bit. So step 5 is going to be the measure of AB equals the measure of BC, the measure of HF equals the measure of FD. And let's go ahead and throw this one in there too. Same justification. May as well. That the measure of AC equals the measure of HD. Right? Because definition of congruent segments. Definition, congruent segments. No big deal, right? Blammo. Blamio. All right. So now we can start substituting. Well, no, we're just kidding. We can't. We got to do segment addition, right? So segment addition. We've got that the measure of AB plus the measure of BC equals the measure of AC, and the let's go ahead and throw the bottom one on there, the measure of HF plus the measure of FD equals the measure of HD. Oop, that should say 5, shouldn't it? Five, and this is 6. This is segment addition. Right? Easy peasy. Crunchy. All right, so now we can start substituting stuff in. Now we can start substituting. We already figured this out. We've already kind of talked through the bits. We can take and substitute and make this. We want it to be AB, so we can turn this BC into AB because of this right here, right? So let's start writing stuff. So 7, we've got the measure of AB plus the measure of AB, right? Substituting this AB in for BC equals, and we're going to make these the same. We said we're going to make them both HD. So we're going to take and substitute this one into this one, right? So this turns into the measure of HD, right? Then we're going to do the same sort of thing on this next line. It's all substitution. It's all stuff from up here down there. So we can go ahead and put it on the same line. No big deal. We want it to be HF. So we're going to turn this FD into HF because of this line right here. So the measure of HF plus the measure of HF equals the measure of HD. All right, now they're both, now this side and this side is equal to both equal to HD. This was substitution. Right? So now we can say the measure of AB plus the measure of AB equals the measure of HF plus the measure of HF because we're taking and we're substituting this into right there, right? So 8. The measure of AB plus the measure of AB equals the measure of HF plus the measure of HF. Also because of substitution. Right? Right. Now, measure of AB plus the measure of AB equals the measure of 2AB. Two times the measure of AB equals 2 times the measure of HF. So what is that? What is that there? It's like adding like terms, right? So technically, if we go back to Algebra 1 and we were doing this as one of those kind of early proof things that you do with properties of equations and all that kind of stuff. This, it would actually be substitution. And so that's what we're going to call this there. So, and it's substitution because of a property that exists in algebra. So substitution due to algebra. You could also, and I've seen this in proofs, and actually we may write this this way. It's not necessarily a bad thing. Either way, it's a little bit janky because it's not in the proof, either one. But we could just say algebra here, and I think we're going to do that. I may even in parentheses, just for clarity, put add, oops, not and, but add like terms right? Something along those lines makes sense. Now, this next one does have a name. So we've got 10. We've got the measure of AB equals the measure of HF. So we divided the 2's off. This is the division property of equality, right? We divided the 2 off. Division property. We're going to have a second column over here. We're almost done, though. Property of equality. Okay. So step 11. Step 11 is going to be, we've got to turn this back into congruent. So AB is congruent to HF. So we've got this now, right? On our thing, we're there. We're basically there. We're just going to write the last step over here on the side. AB is congruent to HF because of definition of congruent segments. Right. So let's continue. Over here, statements, justifications. For the last thing that we need to write is, so if you're one of my students, hopefully you watched all the way to the end of this, because I have news for you. We're pushing this is Christmas break, and this is turning out to be a 40-minute video, which I'm happy about because I feel like it was useful to take the time to hit some of those things to make sure we were doing well. We're going to switch due right after Christmas break. Instead of having 2 lessons due, we're going to have 1 lesson due, and it'll be this one. So everything will get shifted back. I'll give all the extra dates either in email or in class, probably in class. So hopefully you watched this whole video and all the things and took the notes, because then you'll have a clue what's going on. So last thing is ABFH is a parallelogram because pair of opposite sides is both parallel and congruent. And that's it. So I hope this was useful to you. It ended up being a little bit long one, but again, I think we needed to take the time on some of these things to kind of continue to refine what we're learning and make sure we're leaving no child behind. Thanks, George Bush or something. And all of those things. So hopefully this was useful to you. If you're one of my students, I'll see you next year. Do your homework, all of those things. If you're not one of my students, thanks for joining us. Hopefully this was useful to you. Anybody and everybody, don't forget to like, comment, subscribe, all the things, that YouTubers are supposed to say. I know it's in a real YouTube channel, but whatevs. I'll see you later. Bye-bye.